Hi there, it's Mrs. Flynn.
Miss Stadnick.
And we're here today to talk about expanding binomials.
All right, first let's consider what happens with the numbers 2 plus 7 times the quantity of 4 plus 3.
So if we were just to follow our correct order of operations, this would mean 9 times 7, which is just 63.
But we also know that this is actually an area problem, so length times width are given to you here, and we can find the area of this rectangle. So 2 plus 7 is 9, so we know that our length is 9.
So if we have a unit of 2 and then 7 here, this could represent our length of 2 plus 7. And then we could have a width of 4 plus 3. Back up here and erase that. All right, so here is our rectangle.
So if you do 2 times 4, we can see that this first little rectangle has 8 pieces, 1 pieces.
So 2 times 4, this area here is 8.
And then we'll just imagine the rest of the tiles so we don't have to draw them in. But 2 times 3, this one would be 6. And then the next square would be 7 times 4, which is 28. And 7 times 3, which is 21.
All right. So
if we add up the insides, you should get the same answer that you got earlier, 63.
So let's see, that becomes, oh, yep, 63. Okay. So now next we can think about in the same problem in relationship to area.
All right, so we are going to redraw our rectangle, and we'll have 2 plus 7 on the side. And this time we won't completely draw it to scale. We'll just imagine that it is. And then the top will be 4 plus 3. All right, so what we notice when you're doing 2 times 4, you get that 8. What you're basically doing is you are distributing the 2 to the 4 and to the 3.
So if we just look at just this rectangle, you're saying?
Yes, so then we can write it using algebra as 2 times the quantity of 4 plus 3.
All right, so we're looking at this giant, so that means that we have a length here of 2 and a width here of 4 plus 3.
All right, so let's look at the other rectangle. You should have that 7, and then you're going to distribute that 7. You're going to multiply the 7 still to the 4 and to the 3.
So again, length of 7 and width of 4 plus 3.
Exactly. So what you should always see when you're doing it algebraically like this is the 4 plus 3 gets repeated twice, because it's basically like doing 2 separate rectangles. And now we can just distribute it like we've already done before.
All right, so to distribute the 2, we go 2 times 4 plus
2 times 3
plus
7 times 4
and plus
7 times 3. And it should be the same thing that we got on the other side.
8 plus 6 plus 28 and 21, which gave us a total of 63.
All right, moving on to number 3. We'll just come back to this after we look at our specific example. A plus 5 times the quantity of A plus 2.
So if we think again about a rectangle, A plus 5, so we have some value here, A plus 5, that's 1 length. And our width being A plus 2. Maybe it would be better if I write it up and down here.
I think yeah, that would be helpful.
All right, so we could write A plus 2.
So we can pretty much break this up into 4 different area problems. We know that A times A is going to be A squared. And then A times 5 is going to be 5A. Let's look at our second one. 2 times A is the 2A. And then lastly, we'll have that 2 times 5, which is 10.
All right, so if we combine like terms, we'd have a squared plus 7a plus 10. All right, so if we look back at number 3, we could just take this problem here and bring it back to number 3 and talk about the method that some people use called FOIL. So to do FOIL, F stands for first. First represents your first terms. So we would multiply a times a.
All right, the next one is O for the outsides. Outsides are basically the last numbers in your, outsides would mean the very outer numbers, so A and then the 2.
All right, so plus a times 2. All right, and then the insides here being I, that's 5 and a, so 5 times a.
And finally, the last numbers of both binomials are 5 and 2, so you'll multiply those.
All right, and if we simplify this, we have a squared plus 2a plus 5a plus 10.
So your simplified expression is a squared plus 7a plus 10.
All right, so that's one way you could do it without thinking about the area model. So let's go back to the last example here, and let's solve this one without using an area model.
Yeah, let's just do foiling.
Okay, so first terms, a times c.
Outside terms, a times d.
Inside terms,
B times c.
and last terms.
B times d.
So I'll just write it without my multiplication symbols. AC plus AD plus BC plus BD. You have a few problems that you can try on your own now if you're feeling comfortable. Otherwise, you can go ahead and watch the next podcast and do them with us. Bye.